What's up, everybody? How's it going? Happy Thursday. Just seeing one of my kids getting in the fridge over there. It's all good. Yeah, it's fine. Enjoying some hint water. Yeah, hope you're doing well. Happy Thursday. Hope it's going good. I'm gonna do something a little different tonight on the stream. I had someone ask if I could kind of go through and explain a little bit more. So a couple of weeks back, or actually, gosh, 2 months ago or so, I did a video on sort of how to shortcut the Leetcode process. And what's up, rollers? Good to see you. And the videos had like hundreds of views on YouTube, which is great. And I love that that's helping people out. And basically, what I do is I talk about how to go to Leetcode and sort of reverse engineer, someone else's answer to try to learn the strategies. Because when it comes to studying Leetcode, like, sorry, every time I get on the microphone, I get some in my throat. When it comes to Leetcode, and kind of the common Leetcode interviews that we do, a lot of people are just like, I'm just going to grind on Leetcode like all day, every day for like hundreds and hundreds of problems. In fact, one guy that I follow here on Twitch, Midnight Simon, he just did something like 150 days in a row, and he actually interviewed at Google today. So I'm actually really curious how he did on that. I want to check in on him later on. Maybe we'll raid him after if he's online. I'd love to kind of find out how his Google interview went. But he was literally like grinding like several Leetcode problems every day for like 150 days straight. And I think that there's a better way that we can sort of look at those strategies, or look at how those problems are being solved, and try to come up with these high level strategies to try to study. And so what I wanted to do today on the stream is kind of show you how I would, go find a problem that I haven't never seen or never solved, and how I would actually reverse engineer it and try to get an idea of what some strategies are, and then what I would do from there. So I want to dive in on that a little bit deeper. But as always, I mean, I'm here for interview prep and job coaching. So if you've got questions, please drop them in chat, and I'm happy to take a pause and kind of address those as we go. Or if you want to like dive in and like give your feedback on the whole Leetcode process, please do so. I'm a big fan of just hearing a lot of people's perspectives and hearing other people's thoughts on things. So we're not just here to listen to me. I also want to hear from all of you too. So we'll get going. See, aside from that, the only other really big thing going on this week, besides like a crap ton of dental work and more physical therapy, our 13-year-old decided he wanted to do a plague doctor costume for Halloween. So 3D printed this. I'm just waiting for some of the glue to dry, and then gonna get all the priming and the painting and stuff like that done. He wants to paint it black, and then he wants to do like gold stitches down the front and do the eye sockets in like a silver or something like that. And the person that modeled this tried to do it in a way that they could continue to wear glasses. And this almost fits my face, but wow, those crazy glue fumes in there are like horrendous. I might have to cut up some air holes. He's gonna pass out if he puts this thing on. So I shrunk it down a little bit smaller from what would normally fit my face, and hopefully it'll fit his face just fine. But yeah, it was pretty fun to print. Comes in a whole bunch of pieces, and took about 24 hours for all the green parts, and about another 10 hours or so for the blue part. So yeah, just waiting for that glue to dry and hopefully relieve some of the fumes. Got to sand it down, prime it, sand it again, and get like a cover coat on there. So good times. Hope you're all doing good. So I'm going to dive in on the Leetcode stuff. Turn my mic down a little bit. Actually, looks like it's pegging a little bit. There we go. So I'm going to go through kind of my Leetcode process, and I think it's kind of a good idea to think about Leetcode, whether or not you're interviewing, because you never know if you're going to need to interview, and then suddenly you've got to be practiced on these things. Or if you're coming, just finishing up school or coming out of a code school, it's a good idea to practice some of these Leetcode problems more for the problem solving side of it. And so that's basically what I want to go through as part of this process is trying to determine how did somebody else solve the problem. And so let's dive in a little bit. I'm going to switch my view over here. And all right, so what I did is I just pulled up this problem. I've never solved it. I know how to solve this one because I've seen this one in the past. But what I want to do is show you the process that I would follow if I had never seen this one before, and then I'll pick like a couple at random and kind of show you what I would do from here. So the general premise of this problem is you've got an integer and you want to find out if it's a palindrome. So it's the same number backwards and forwards. Well, in a lot of programming languages, you could, so like switching over to Python, for example, I could do like get a string representation of X, and then I'm going to like reverse it and then cast that back as an integer. And then if that's the same as X, so we're basically going to return that. So we're basically going to convert the string, or convert the integer to a string. We're going to reverse the string. We're going to turn that back into an integer and compare it against the original integer. But most interviewers aren't going to want you to do this. They'll probably tell you like, hey, it's not a very efficient way of doing it, or, you know, I want to know if you can actually like break the problem down. And there's a way that we can do it with the modulus operator where we basically carve off a digit at a time and reassemble the number. And it's actually much, much faster. I actually benchmarked this code written in Go the last time I benchmarked this, and basically running like the first 10 million numbers to compare like how many were palindromes, doing the string conversion, and then doing kind of this math operation that you can do. The math operation was about 25,000 times faster. Like it took about 6 seconds to burn through like 10 million numbers, and it took like milliseconds to do it with the math operation. Because we built these computers for math. We built them to like fly us to the moon back in the day. And so they're really, really, really fast at math, but they're less optimal for, you know, doing all this memory conversion and memory cleanup and all the garbage collection and stuff that has to happen. So that's the really high level, and I also know the math formula for doing it too. But I want to show you kind of the process that we would do here. So all we know is that this is the code that Leetcode is giving us for Python. So what do we do from here? How do we go find someone else's solution? And basically what I'm going to be doing kind of throughout the session here is I'm going to be, you know, kind of copying some of the notes from Leetcode, and I'm going to put them over here in my code editor and show you how I'm going to like copy someone else's solution, turn that into some pseudocode, and then how I might compare like multiple pseudocode together. And so let's expand some of this stuff actually before we dive too far into here. This is all my interviewing.io stuff. Let's make a new folder in here, and we'll just call like Leetcode grind. And inside of here, I'm just going to call this like pseudocode 1 text. And I'm just going to copy this a bunch of times. So basically what I'm going to do is I'm going to go find 3 different solutions, and we're basically going to write out the pseudocode for how someone else solved this problem. Now, because I know Python, it's not really going to be it's not going to be a good use of my time just to go look at another answer in Python. Because what's going to happen is by looking at a programming language that you already know, it's going to force you into low-level thinking where you're looking at the syntax and you're going to memorize the syntax of how to solve the problem. And what we want to do with this process is extract the strategy of this. So what I'm going to do is I'm going to go into the discussion forum for this particular problem. So what we're going to do is we're going to click on that discussion link. So the description is the problem itself. So I'm not going to the main discussion link up here at the top. I'm going to the discussion forum for this particular problem. And what we're going to find is we're going to have like a whole bunch of different solutions in here. Now, I can read Go, I can read JavaScript, I can read Java. Don't like to read Java. Python solution without string, C++. Not as familiar with C++. I can get by in C++. I know Ruby. So what I want to do, though, is I want to try to find a programming language that I don't really know. I don't really know C#. Using read-only span, but that looks like it's converting it into a character, so maybe I don't want to do that one. So I'm just going to keep looking for an answer here until I find like a programming language that I don't know, and then I'll explain why. And if I can't find one pretty soon, then I'm just going to go ahead and grab one in Java or something like that. All right, C#. Okay, so if I didn't know anything about C#, by copying this person's solution over here into my editor, let me go back over to my editor. And what I'm going to do is I'm going to paste in their solution over here. Oops. That's not what I want to do. There we go. So what we want to do here is I basically want to turn this into pseudocode. Now, by looking at this in a programming language I don't know, it's going to force me into higher level thinking and trying to imagine what is this code actually doing. So by looking at an answer in a programming language you don't know, it forces you into thinking of high level sort of thinking. But again, if I were to go look at an answer in Python, I'm going to memorize the syntax, and this is all about strategy. So for this kind of problem, what I want to do here is I basically want to unpack like some of this stuff a little bit here. So we're basically saying if x is less than 0, then it can't be a palindrome. And if we go back and we look at the description of the problem, it actually doesn't give us that as a, oh, it does give us that as a constraint. So if it's a negative number, it's immediately false. Because if we reverse it, it would be 121 dash, therefore it's not a palindrome. So I guess we can kind of conclude from that any negative number is not going to be a palindrome. Although it does give us a constraint saying that it could be anywhere from negative 2 billion to positive 2 billion, minus 1. But basically a 32-bit integer is what we're going to deal with here. So in this other person's solution, let me go back over to my editor. So in this person's solution, they're basically saying if it's less than 0, it's immediately false. So what I want to do is I want to write this out as pseudocode. So I've got my function where I'm passing in my number, and we're just calling it x. And inside of here, we're basically saying if number is less than 0, then false. Now this next part here, we're basically saying if it's not 0 and x modulo 10 is 0, then it's also false. So what is x mod 10 going to do for us? Well, x modulo 10 is basically looking at just a single digit at a time. And so I think this is basically saying if it is exactly 0, x mod 10, that just means it's a multiple of 0, or a multiple of 10. So if the number itself is a multiple of 10, then it can't be a palindrome. Like 100, for example, can't be a palindrome. 10 can't be a palindrome. 1,000 can't be a palindrome. 10,000 can't be a palindrome. And so we're going to add that on here. So if number is a multiple of 10, then it's also false. So again, when I'm writing out the pseudocode here, I don't want to get really hung up on the implementation. I want to write this out in very high-level, vague terms so that, you know, I can actually go try to process this in an efficient manner in my own programming language. Now, this person, they're looking at length, so they are converting it to a string and grabbing the length of that. So let's write out that pseudocode. So convert int to string and get the length. And then after this, what they're doing is they're doing a for loop based on the length of that number divided by 2. So they're basically going to work through half of that string. So we're going to loop over the first half of the characters in the string. and inside of that loop, and so this is where I indent my pseudocode a little bit. So I'm kind of getting an idea of what the shape of my code is going to look like. So as I loop over the first half of the characters in the string, what is this code doing? Well, it's basically saying if my, and so I've got an I element, which is kind of like an index position into the array of the string characters. And we're basically saying if that string character is not the same as kind of the opposite end. And so it's basically setting two index positions and it's walking them together because we're taking that value of I, but then we're also doing the length minus I. And so when it's 0, it's also the end of the string. And when it's 1, it's the length of the string minus 1. When the position is 2, it's length minus 2, and so on, until we get halfway through. And so it's basically just comparing each end of the string, comparing it character by character. And if at any point those don't match, it's going to return a false. So for the first half of the characters, if this index position doesn't match the opposite end, then we return false. Otherwise, if we get all the way through the loop and we don't return on line 21, then we can return a true value that says this number was a palindrome. So this is pseudocode number 1, even though I saved it in a file called pseudocode number 3. This is just one answer that we're going to take a look at. So if I come back and we go look at someone else's solution now, go back into that discussion forum, and let's go find one in Java. And here's their solution. And again, I'm just going to paste this into my editor. And I'll do this as another pseudocode. And I'll show you why I'm doing this as separate files, kind of as we go. Now, the indentation got kind of thrown off, but that's okay. All right, so let's go see what this one's doing. So we're in a class. We've got a public function that's returning a Boolean. I have to fix some of the other indentation in here. Okay, this looks right. Okay, so here we've got our function and we're passing in our x value. And inside of this function, we've got something called org, and we're setting that to n. So it looks like we're saving a copy of the original number. So save a copy of number. And then it looks like we're building a temporary number. So we're going to initialize a temporary number. And what this part is doing, this is kind of that math operation I was alluding to earlier, where they're basically like shaving off one digit at a time. And so what's happening here is they're basically saying, take that number, mod 10. And so if we have a number of 1, 2, 3, 4, and we modulo 10 on that number, it's basically going to give us this number 4. And so what this is doing is it's saying, hey, take that number 4 and add it to whatever was in temp originally, multiplied by 10. And so what's going to happen is it's going to give us this 4, and then we're going to store that 4 inside temp, because temp starts out as 0. So 0 times 10 is going to be 0. And then we add the last digit. So now our n value is going to be, or sorry, our temp value is going to be 4. Now we do an integer division here that basically divides it by 10, which then removes that digit. So it's going to do like 123.4, like 123.4, but dividing it by 10 then is going to strip off that decimal point. Time to get swifty. Good to see you in chat. First time chat. Hello, your name is Hayden. You were part of the cohort you visited for lunch last week. Good to see you, Hayden. Thanks for hanging out. So yeah, tonight, I mean, I'm happy to take Q&A in chat as always. But basically what I'm working through is how I reverse engineer Leetcode problems to kind of look at the strategies of them. And what we want to do is we kind of want to get into the mind of other people and see how other people solve these problems. Because sometimes just looking at a Leetcode problem, you're like, huh, I don't even know like how to get started on this. And so what we're doing is we're basically looking at other people's answers and we're turning it into pseudocode. And then I'm going to show you how I compare the pseudocode so that we can kind of extract like high-level strategies for solving this kind of problem in the future. Cool, mcode 913, good to see you in chat as well. All right, so by doing this integer division then, we're basically changing our number from 1, 2, 3, 4 into 1, 2, 3. And then we're basically sitting in this while loop as long as n is greater than 0. And so the next time we come through, we trim off that last digit again. So now 1, 2, 3 mod 10 is going to give us a 3. And then we're going to take what was in temp and we're going to multiply it by 10. And then we're going to add the number from up above. So we're going to add that 3. So now temp becomes 43. And the next time through, it's going to give us, then when we do that division by 10, now we have 12. So 12 mod 10 is going to give us the 2. We multiply this by 10, and then we add that 2. And so you can kind of see how this math operation is basically just carving off a digit at a time and reassembling it in that reverse order. And then they're basically checking here, is this the same? So we're basically saying, well, number is not 0 yet. We're going to trim a single digit using mod 10, and we're going to add that to temp times 10 until our original number is 0. So what we want to do now is we want to do an integer division by 10 on our x number. And then from here, what we can do is we can just return. This is like a thing that really irks me about programming. If you're doing a Boolean operation to hand roll your own like Boolean response, why not just do like return temp equals org? And then you don't even have to worry about this whole if else statement. So what we can do here is we can just say return whether original number is equal to flipped number. So this is our second algorithm. So that's basically how I reverse someone else's code into pseudocode. All right, cool. Just keeping an eye on chat. And yeah, as always, if you do have questions about interview prep, career coaching, anything like that, I'm happy to address that. So feel free to take me off topic for the night. That's totally okay. All right, so let's go back over to our browser. Let's go grab another answer. So we found one in C#, we found one in Java. Let's go look at C++. So the C++ one, this looks just like the Java one, where we're basically keeping a copy of the original number. We're keeping a copy of the original, we're building a new temporary one, and then as long as it's greater than 0, we're doing all this other work. Greater than or equal to 0, and then basically doing the same math operation. And then they're doing the same, if it's equal, then return that. And so because that pseudocode would be exactly the same, I want to see if I can find someone's code that's a little bit different. This one is also a little bit different as well. So I'm going to go grab this JavaScript answer, and we'll go throw that into our editor here as well. So this will be our second pseudocode. All right, so what's the pseudocode doing? Well, we have our function with our x value, and inside of here, it looks like they're converting to string. So they're converting x to a string, and then they're setting 2 pointers. So pointer 1 is set to 0, pointer 2 is set to string length -1. And then they're setting a result flag. So they're set a result flag, and they're defaulting to true. And then they're basically sitting in a while loop. So while the pointers, so while I is less than j, and then I can see that they're moving one pointer ahead and they're moving the other pointer backwards. So what I'm going to do here is I'm going to say while the points haven't crossed yet, or actually while our pointers haven't crossed yet. What do we want to do? So now we're basically saying if character at I is not equal to character at j, then in this case they're actually doing a break, which is going to break out of that while loop, and they're setting that flag to false and they're returning that. But it would be faster in this case just to return a false right here. Otherwise, if we get out of that while loop, then we can just return true, because if we didn't exit early, then we know that it passed. So now we can get rid of this as a flag. So again, we're basically just trying to get into the mindset of like, how did somebody else solve this? So now what I want to do is I want to show you how I would compare all of these pseudocode pieces to see if there are like common strategies in all of them. So let me figure out a way to get them all on the screen at the same time-ish. That's not going to work. Let's pull this one down here. All right. So what I want to do from here is I basically want to examine all of the pseudocode together. And this can be really helpful if you do like 4 or 5 different pseudocode as well. And I think it's just an interesting way to like get into the brains of other people and see like, is there a common pattern in all of this? So in this case, if the number was less than 0, it was immediately false. If the number is a multiple of 10, it's immediately false. That's pretty unique. This part that I'm highlighting here is unique across all of the other pseudocode. Nobody else does this kind of thing. But eventually they're getting to the point where they're converting it to a string. They're storing the length, very similar to what we did in this JavaScript one up here. The difference with this one is that this one was looking at the first half of the characters. This one was also kind of looking at only half, because as soon as, the other thing that we forgot to do here is we want to increase I and decrease J. Because if we don't do that, then we're stuck in an infinite loop. But as soon as those cross, then we know we've already met that halfway point in our string. And so in this case, this while loop is effectively doing the same thing. So we're looping over the first half of the string. Over here, we're looping over the first half of the string because of how we were manually manipulating these pointers. And then the inside of this is basically the exact same thing. If this index position doesn't match that opposite end, then we immediately return false. And so this block of code between what was our C# answer and what was our JavaScript answer is actually the exact same code. Now, one was doing it with 2 pointers. Another one was just, walking over the first half. And what they were doing is they were using that I value then, and also grabbing the length of the string -1 minus I, like every iteration through that loop. I kind of like this one a little bit more because you can, at least I can visualize that a little bit easier than trying to imagine like, okay, well, I got to go get the length every time, -1 minus whatever my I value is. I might as well just have like this J value and decrease at each step. Cool. Time to get swifty. Just here hanging out. Interesting to see you work these out with lots of experience versus me freaking out with just 4 months of practice. Yeah, I freak out over some of these too. Not gonna lie. Like Leetcode stuff is pretty intimidating even with 25 years of experience. If I were to go job hunt right now, I would absolutely be peeing my pants at the thought of having to go grind Leetcode for weeks and weeks. And so what I like to do is kind of follow this process of, okay, I don't immediately know how to solve this problem, so let me go find other people's answers, reverse engineer that into pseudocode, and then write my pseudocode in a way that I'm not locking myself into an implementation, and then go see if I can actually implement that in my language of choice. Now, this math operation that was happening here, this one ended up being unique of the 3 different pseudocodes that we basically came to. And then, we're just returning whether that original number matched the flip number. So in this case, if the number is negative, then that last digit that we'd be putting on here would be a negative number. And adding that negative number then is actually going to like mangle the number that we were doing the multiplication by 10, and then adding that negative number is actually going to decrease the number from there. And so they are not going to match. And so this would still give us an accurate representation even if the number was negative. The difference here is we're immediately stopping if we know the number is negative. We don't even have to go through and like shave off digit by digit. So we don't have to do all of this work. So this would be actually a really good check to do ahead of time, as well as like the multiple of 10. Because if it's exactly a multiple of 10, then we know it can't be it can't be a palindrome. Cool. Carmen, good to see you in chat. In my opinion, what are the most important areas to focus on while on the job hunt, like whiteboarding, GitHub, resume, networking, etc.? I've heard a lot of companies are steering away from on-the-spot whiteboarding. Yeah, I've heard mixed things. By whiteboarding, I'm curious if you mean that they're actually like stepping away from like Leetcode style problems. I have heard, for example, that Amazon and Facebook are not doing dynamic programming problems anymore, specifically those. But when I interviewed at Amazon back in the day, this was long time ago, long time ago. They asked me all like graph traversal questions. So it was a lot of like A-star and Dijkstra and depth first search and breadth first search and directed graph theory and all that kind of stuff, which I was happy to study back then because I wanted to work at Amazon. Now, not so much. And so I'm happy not to have to go study those things. When it comes to like all of the different things, I think that every technical interview is going to have some aspect of like, show us that you can write some amount of code. Maybe it's not like a full-blown Leetcode problem, but being able to demonstrate like that you can write some code. I think some companies are going to have you do some bit of live coding. Just what does that actually look like? Now, if they're doing like a take-home assignment, some companies are really cool about, hey, bring that take-home assignment back, because when we do like our on-site or virtual on-site, we actually want you to work on that code. And it's code that you've written, so you know it really well. And so you're able to go in and like implement changes in that much easier. Now, I do like to tell a story how back in the day, I gave somebody a take-home assignment and they handed it in and it looked great. So I brought them on site and I'm like, hey, I found a bug and I want you to add a new feature. And they're like, oh, shoot, I'm working on that code. I'm like, yeah. And they're like, oh, and it turns out they didn't write the code. They had their friend write their code for them. And I'm like, why would you do that? I guess they thought that, you know, as like some companies, when they give you a take-home assignment and they evaluate it, they just throw it out. But not me. This was back in like 2011, 2012. I'm like, no, bring that code back in. I want you to keep working on that code, because it brought their stress level down. It was code that they were already familiar with. And so it tended to bring their stress level down quite a lot. I'd be like, bring your own laptop, bring, you know, whatever editor you're comfortable in. And so all the familiarity, you see that stress level kind of drop and you see that anxiety go down, and they tended to perform better in an interview. Go figure. When it's not as nerve-wracking, people tend to do better. But there's one guy, he came in and he had his friend write the code because he thought it was going to be throwaway code. And he also didn't, I don't think he even looked at the code himself, because he didn't know how to fix the bug and he didn't know how to go implement some new features. Like, do you even code? Like, you know, it's just, it was like, it was an implementation of the old riddle of like, you have a 5-gallon bucket and a 3-gallon bucket and you have to measure 4 gallons of water. And I basically had people build like just a really simple form where I could enter any two numbers plus a target, and you tell me whether it's possible or not. And so it's just the math operation of like, how do you add the buckets together to get the result? And the code that was sent in didn't do some validation. Like I could put in letters and it would just completely crash it, or I could put in negative numbers and it would completely crash. And so I wanted him to go fix that and like add some validations to it. He had no idea what to do. He had no idea where in the code to even go like start finding that. And it's like, well, dude, like on the job, your first day on the job, I'm going to be giving you a bunch of code you've never seen before. And you're demonstrating during the interview that you're going to struggle with that on day one. Like how do you expect to do the job here if you can't look at code that you've never seen before and try to fix bugs or implement features? Like that's everything you're going to be doing on the job. So needless to say, they didn't get hired. I've heard from folks interviewing recently there were more take-homes or pair programming with a dev. I love the idea of pair programming interviews. Pivotal Labs, I think, was really, really good about this. I don't know whether they still do the pair interviews, but they really enjoy doing pair interviews where you would sit down with them and they would typically have you working in a technology that you weren't familiar with, again, to kind of test your knowledge about high-level concepts of, you know, do you understand good object-oriented programming? Do you understand, you know, how to do test-driven development at such a high sort of functional level that you can just describe to me what to do? So I'm the one on the keyboard, so you just describe to me what I should do and let me worry about the syntax. And what I would typically coach people to do for those kinds of interviews is, if you're in a pair interview, ask if you can try, watch how they're actually writing the syntax and watch kind of the workflow that they do. And then ask whether you can try writing a little bit of code. They may say no, don't worry about it, because they know you don't know it. But if you can say well, I've been watching for a half hour, an hour, I think I kind of got the idea about the syntax. Do you mind if I try? And you can just kind of correct me kind of as we go. And I found that the people that I would coach with that, they tended to do a little bit better on those interviews, because again, it's showing the grit of I'm willing to get in there and roll up my sleeves and actually get in there instead of just sit here and just describe things. I actually want to be involved in this process. Zooey says they get nervous with pair programming. Yeah, and we tried pair programming at SendGrid as well, and we had mixed results. Some people did really well with it, some people did not. We also questioned, and some companies question, do we have you work on real code? Do we make you sign a non-disclosure agreement and make you work on real code? Because now you're actually working on real code with us, but we're not paying you like an employee. So should we be having you work on real code? Or it starts to get really kind of blurry as far as where to set the limits on that. But we found that the pair programming was actually a really good determiner of collaborative teamwork, and how well you could communicate your ideas, how well you got along, how well you could kind of quickly learn kind of our process of how we did things. And I actually really enjoyed doing pair programming interviews. Time to Go Shifty was talking about the person that had his friend write the code, so they were just outsourcing. That's a good point. So I actually wrote up that story on Quora, and it got quite a lot of upvotes and over 1 million views or something. And the number one comment I got on it was did you hire his friend? It's well, no, I'm not going to hire his friend. He was obviously in on it. Why would I hire someone who's willing to also be dishonest about the whole thing? So, I mean, it's not I would go to my friend and be dude, could you write me a piece of code that does this thing? He'd be why? I'd be no reason. I mean, his friend had to have known or guessed that, it was going to get submitted for an interview. So it was shady all around. Anyway. Carmen says communication is really big in pair programming. Yep, talking about it, asking questions, going down rabbit holes together especially, yeah, sometimes eases the nervousness. Yep. Did his friend write good code? I mean, it was good enough to pass my rubric of it's good enough for an on-site interview. But yeah, they just had no idea what to do with it once they got on site. So anyway, so that was that first problem. And basically kind of breaking it down into, let's turn it into some pseudocode. Let's try to see what these high-level strategies are. Let's try to find commonalities, and then, let's see where we can take it from there. So let's go do this with some other problem. So I kind of picked that one at first because I had seen that problem in the past. So I've never solved it on Leetcode, but I've known the algorithm for that one. So let's go find a problem that I've never seen. And there will be plenty on here. So let's go look at Leetcode problems. Oh, I suppose I should show you my browser. Let's see, Roman number to integer and back. I know those. Threesome, medium. Let's do an easy one just for today. Valid parentheses. Merge two sorted lists. All right, I haven't solved this one. All right, so we have two sorted lists, and it looks like they're linked lists, maybe. Or they're just arrays. And we basically need to merge them together into a single array. All right, so let's imagine I have no idea how to solve this. What I want to do is and I always recommend take a crack at it, try it. And if you're really, really stuck, then this is kind of the process that we're going to follow. So we're going to go into that discussion forum for this problem. And what we want to do is we want to try to find a handful of answers in a language that we don't know, and then figure out how do we build the pseudocode based on that answer. Again, we want to get into the head of the person that wrote that solution and try to understand the strategy they followed, because we can learn from their problem solving. And then maybe we'll become a better problem solver by seeing how someone else solved it. Because sometimes it's difficult for me to come up on the fly and go, yeah, how would I solve that? Let me think on it for a little while. But if I can see how someone else solved it, then I can do it too. I think a lot of us are that way. And so I think that this is actually an effective study tool. And now we can go and say, okay, well, based on this array problem, here are some strategies that I can then use in other array problems later on. If I come across another array problem that's dealing with sorted lists, I've already got some strategies that I can reach for. So we got one in Java. We'll go look at that one, and let's go find a couple others. We got C++, and what other language? Just check in chat, see if anybody's recommending. We got one in Go. Oh, TypeScript. I don't know TypeScript at all. All right, let's go look at TypeScript. I want to go look at that one first, because I've never actually seen TypeScript. All right, so first thing I'm going to do is just copy all that code, and then we'll go back over to my editor. If anybody here knows TypeScript, don't make fun of me while I work through this. All right, so we got TypeScript going. And before we go too much farther, Carmen asks in chat, for interview prep, should you know the proper terms such as what is a linked list, array, hash, graphs, trees? I think having some understanding of what those data structures are is a good idea. I also realized I didn't really answer your question from earlier. So I actually want to go back and answer your question from earlier. So what are the most important areas to focus on with whiteboarding, GitHub profile, resumes, networking, and so on? I would do it in this order. I would say do your networking first, because that can take a long time. So do your networking and your company research. And then while you're coming up with that company research and you realize that this is a company I want to apply to, then you're going to do some resume prep for that. And then I would probably just figure out, like, periodically on a regular basis, how can I practice, Leetcode style problems or some sort of coding or work on a side project or something like that, that I can then demonstrate at the interview that I know what I'm talking about. And so some sort of practice of code. Those, and then from there, like things like LinkedIn, and then like other profiles. Like we talked to Jen a couple of weeks ago, and Jen had put profiles up on angel.co, and I think it's work for a startup.com. Jen put some profiles up on these sites, and employers started reaching out to her. There's also like hired.com. And there are a couple of other sites where you can actually go build a profile, and employers will find you. So I would probably work on things in this order. Now, you could bump these things up to the front of the line and say, like, I'm just going to go build those profiles, and now they're out there. And now I'm going to go work on all this other stuff while people try to get in touch with me. And if they do get in touch with you, then now you can start networking with those companies and start doing your research on those companies to then lead into building them a resume. And I've got a whole video that you can watch on building out the resume, where you start with a really long resume and trim it back down to one page as you apply for a job. I think it's a good practice to get into. For me, it's an easy way of just trimming down the stuff that I think is most relevant for them to see. And then, yeah, you're pretty much just always going to practice coding all the time. So maybe LinkedIn could be up here at the top as well. Because that's kind of like a one-off kind of thing. Like, it's not like you're going to constantly go into LinkedIn and like constantly make changes. So these are more like one-off kinds of things. The resume will happen as you find a company that you actually want to apply for a job. And then just kind of all the time, you're going to be practicing coding. So hopefully that'll give me my 2 cents at least on kind of the order of operations there for doing that kind of stuff. So yeah, so going back to your next question then, like, should you know about like specific terms like linked lists, arrays, hashes, graphs, trees? Yes. And I would say for data structures, you probably want to look at, definitely arrays and hashes, sometimes called lists and dictionaries respectively. So some programming languages call them different things. Like in Python, we don't call it a hash, we call it a dictionary. And in Python, we call it a list instead of an array, but it's basically the same concept. They just give them different names. In C++, I believe there's a type of array called a vector that you can dynamically add to, or you can make like a fixed length array. And so there's different kinds of these data structures as well. Like Java has a whole bunch of different kinds of hash maps that you can build. So I would say be familiar with those, and then linked lists would be probably next on the list. No pun intended there. And then stacks and queues are also really helpful for Leetcode problems, and then maybe a binary tree. So if you are decently new in the industry, these are probably the data structures that that I would focus on more. And if you're going for like the big FANG companies, I would definitely throw graphs in there as well, because they do like a lot of sort of graph type problems, and probably also heap problems as well. Heap problems are also really popular at the bigger companies. PDF or doc, are we really going there, Carmen? Carmen's trolling me in chat, everybody. Thanks, friend. No, just kidding. We joke a lot about should you build a resume in PDF or doc format. So, cool. So Zui is asking, what are some typical interview questions for React? I've never used React, so I've never actually done an interview on either side of the table for React. Knowing a little bit about it, though, like it uses components, and the components are sort of compartmentalized and can contain the HTML and the CSS and the JavaScript for that component, so you can reuse that component. They may ask questions about like, how does all that play together? They may ask some specifics about, how would you pull this code, in a way to be reusable? How would you turn it into a component? How would you test that component to make sure that it's always going to do that thing? Or how do you make it generic enough that you could kind of pluck it out and put it in another project of some kind? Like, does it abstract a problem well enough? So getting into some object-oriented terms around like abstraction and encapsulation would be probably good to use as answers for that. But as far as the specifics go, unfortunately, I'm not going to be a good source of information on specific questions for React. But if anybody else in chat has done an interview involving React, if you've got topics and so on that you can share with Zui, that would be really, really awesome. So appreciate anybody that can help out there. All right, so we found that answer in TypeScript. So let's go turn this into some pseudocode. So we've got our function where we're taking in, it looks like we have two lists. So it is taking in a list node or null. List 2 is a list node or null, and it's going to return a list node. So we're taking in linked list 1 and linked list 2, and we're going to be returning a linked list, which I'll just call linked list 3. So again, when I'm writing out my pseudocode, I'm not worried about data types. I'm not worried about making it so specific that I'm locking myself into an implementation. I just want to keep it really high level. And because I don't know TypeScript, this is actually going to show you how I really kind of break this thing down. And so they're basically setting a pointer called new head, which is a list node object type. This looks like this is building that list 3. So we're just going to say initialize a new linked list called linked list 3. Now, how you actually do that in your language of choice, totally up to you. And then we're making a new sort of pointer that we're calling current. We're saying point at that spot. And so we're going to start a pointer called current and point to the new list. Point to the start of our new list. All right, so from here now we've got a while loop. So we're doing a while loop of list 1 and list 2. And so this is basically going to work until list 1 is empty and list 2 is empty. So what I want to do here is I just want to say like loop over, or just loop until list 1 and list 2. Actually, in this case, until one of them is empty, because as soon as one of them has no next node, this condition is going to fail and that while loop is going to stop. So loop until one list is empty. Now inside of that loop, what do we need to do? Now we're checking the values of each node as we go. So we're saying if the list 1's value is less than list 2, then we're going to add that onto our current, and then we're going to advance that list's pointer. And so each linked list has kind of its own pointer, which we're using L1 and L2 as the pointer to the start of those linked lists. So until one list is empty, we're going to say if linked list 1 value is smaller than linked list 2, then we're going to put linked list 1 value onto new list. And then we're going to advance our linked list 1 pointer. Now, the current.next equals that node. This is basically how we're sort of making a copy of that data in this case. Otherwise, our else condition, and in parentheses, even though I wouldn't write this as like an else if, I'm just keeping track from my own thought process here, like linked list 2 is less than linked list 1 as our else condition. So what we want to do here is we want to put our linked list 2 value onto new list, and then advance our linked list 2 pointer. And then it looks like we're then advancing our new lists pointer from sort of that beginning position to the next position. So as soon as we add something onto that new list, we need to advance that pointer as well. So we're going to advance our new list pointer. So now what we want to do is if one of those lists ends early, if one of those linked lists has more nodes than the other, as soon as one of them ends, then all of the remaining nodes on the other linked list, we can just attach the rest of those to the end of our new list. Because we know that these are already sorted. And so, for example, if I've got a linked list of 1, 2, and 3, and another one of 2, 3, 4, 5, 6, basically what's going to happen here is we're going to iterate, we're going to look at 1 and 2. 1 is less than 2, so we're going to add 1 onto our new list. And then we're going to advance that pointer to here. So we're effectively like going to remove it from here. Now we look at these and go, okay, well, neither one is smaller than the other. So one of these is going to have to be a less than or equal. And it looks like it's only happening if it's less. Otherwise, we're taking the value off of the second list. And so we're going to grab this value of 2 off of our second list, and we're going to add that on here. And then we advance that pointer. Then we kind of come back up to that while loop, and we compare the 2 and the 3. We're going to put the 2 on there from list 1. And then the 3s are the same. So we're going to grab the 3 off of list 2 first. And then we're going to grab the 3 off of list 1. But now that list 1 is empty, the rest of these nodes are already sorted. And we know that we can just basically tack that whole thing on there without having to sit in the while loop to do it. So all we want to do here is I just want to say, okay, well, the next thing then is going to be just the rest of the list. And so we can say, like, if list 1 is empty, then we're going to put the rest of list 2 onto list 3. Else, if list 2 is empty, then we're going to put the rest of list 1 onto list 3. And then we're just returning our new list. So then we return our new list. So there's the first pseudocode based on a TypeScript implementation. And then they're giving some time complexity and some space complexity here, where their time complexity is basically the 2 list sizes. So O of M is basically the size of list 1 plus O of N, because worst case scenario, we're iterating over both lists sequentially. And our space complexity is what we say is constant. I would say that this is probably also M plus N, because we're actually adding a new data structure that is the combination. Actually, no, it isn't. Actually, I take that back, because the way that the way that TypeScript is doing its pointers in memory is this stuff is just happening in memory. It's actually not making a third list in TypeScript. It's making a pointer to a new list. But the way that pointer magic is happening, I wish I had a better tool to actually draw things. I think Jonan does a fantastic job of this on his stream. The way that the pointers are actually happening is it's actually pointing to the actual nodes, and it's redirecting information from the nodes, so that at the end of it all, it actually hasn't used any additional space, and so it's actually constant. So, cool. Looking back over chat. So it looks like Carmen's got some information from Zoe about React, so appreciate that. Tell me the difference between use state, use effect a few times. Cool. Awesome. Thanks for helping each other out. It's awesome. JSX, yeah, okay. feel comfortable explaining hooks and states. Cool. Cool. Can I explain what recursion is? Yeah. For a definition of recursion, see recursion. Yeah, we can totally talk about recursion. Let me do that up here. So in a recursive function, recursion is basically just a function that calls itself. And so I could write a function where I take in some kind of input, like an integer value. And what I can do in here is I can basically call that function again where maybe I reduce it by 1. So what I can do here is I can say like print the value of I and then call the function again where I reduce it by 1. But then we also need a stopping point. Like if we get to 0, then we need to stop reducing it. So at this point, I can do what we would call a base case. Like how do we stop the recursion from happening? Otherwise, it's just an infinite loop. We can say like if I is 0 is less than or equal to 0, then we'll just stop. So again, this is how I would write out just simple pseudocode for this. So if I is less than or equal to 0, then we're going to stop doing what we're doing. Otherwise, we're going to print the value, and then we're going to call the function again, but we're going to decrease that value. So if we call this with a function 5, then our output is going to come in here. It's going to say, okay, I'm going to print the value of 5, and then I'm going to recursively call myself with a value of 4, so 5 minus 1. So we're basically starting all over again. We're not 0 yet, so now we're going to print that value out. And then we call ourselves again, reducing it until we get to a value of 0. Now, as soon as we get to 0, we stop. We don't even print that value. But what we would do here as a stop is we would just do a return or something like that. And so what the return is going to do is it's going to go back to where the recursion was called before. And because that was the last instruction, it's also going to return. And that's going to return where it last stopped, and so on and so on. And so it's basically... it's good for what we call dynamic programming, where you have what we would say is a repeatable subproblem. So a repeatable subproblem is like, how do I do this thing again, but with a slightly different input? So like if I had a basket of laundry, I can say I'm going to reach into the basket of laundry and I'm going to pull out a pair of socks and I'm going to put that socks away, or I'm going to put the socks in my dresser. And now I have to repeat that whole process again until all the socks get put away. So now I look at the basket. Do I still have socks? Yes. I'm going to take out a pair of socks, put it in the dresser, and then do that again, and then do it again, do it again. Now, we could just do that in a while loop. We could just say, like while I have socks, just put socks in the dresser, put socks in the dresser, and just do that until the number of socks in the basket is 0. Where recursion comes into play is when we need to really manipulate that data in a way, or maybe we need to call the recursion in several ways that we can manipulate the data in multiple sort of ways. And without going too far off track with that, like the Fibonacci number sequence, for example, is a pretty popular recursive thing. And basically what Fibonacci is you would pass it the number of steps that you want to do. And the Fibonacci thing is like whatever number, or the number that it's returning is the sum of the two previous numbers. And so it would be like 1 and 1, and then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 and 13 is 21, and so these are all the numbers of the Fibonacci sequence. And so in a recursive function, we can actually, we could build that out in a way where we're kind of relying on things that we've already pre-calculated, like we could cache those values, so we don't have to do the math over and over again. Because if we recursively call a Fibonacci thing saying, I need to go find the value of 5, or like the step for number 5, I don't want to have to go and calculate that all over again. And so it's a good way of just reducing the amount of work. So typically in recursion, you'll see some kind of caching, also called memoization. It's like the word memorization without the R in the middle. So memoization is typically seen in recursive functions as well, just so you don't have to do the same work over and over again. Hopefully that helps. Cool. Is recursion preferred over other approaches? It depends. There are some algorithms that are better served with recursion than doing it like in a more iterative approach. Like earlier in the stream, I talked about depth first search, which is a way of like if we think about things in a tree sort of fashion, we can kind of work our way down the tree and then backtrack and then go down like a different path and then backtrack and then maybe backtrack again and go down a different path and so on until we find an answer that we're looking for. That lends itself very well to recursion, where you end up with a lot less code than if you wrote it out as a manual process. There's an interview challenge question that I like to ask, which is basically you've got a menu of items and you have a total amount of money and you have to try to figure out what can I buy off the menu for that total amount of money. So if we imagine that we had a food truck outside and they had a $4 sandwich and a $3 salad, how would we spend $10? Well, as a human, I could look at that and go, okay, well, if I got $10, I'm going to buy a sandwich. I got $6 left over. And so just glancing at the menu, I can say, oh, I could buy 2 salads. So 1 sandwich, 2 salads. But when we think about these kinds of problems when it comes to tech interviews, we have to think about, well, how do we tell the computer to do those steps? Like, how did I just jump from buying 1 sandwich to 2 salads to getting an answer? Like, as humans, we can kind of jump to that conclusion very quickly because it's easy for our brains to recognize those kinds of patterns. But for a computer, it's not as easy. And it's also a little trickier if these things had like decimal point values. Like if a sandwich was $4.50 and the salad was $3.50, could we even spend exactly $10? And so we have to think of like what those steps would be. So a recursive function for something like this is a depth first search. We would pass in like an amount of money and maybe a menu of our items. And then inside of here, we have to loop over that menu. And then we're going to try to buy that item if we can afford it. So we're going to skip this item that we're iterating over. We're going to skip the item if it's too expensive. Otherwise, we're going to try to buy the item. Now, again, I'm writing out my pseudocode in a way that I'm not really putting myself into an implementation. Like by collecting that item in some way, am I putting it on a stack? Am I adding it to an array? Am I putting it in a hash or a dictionary of some kind to track what I'm buying? I don't care at this point. I'm just writing pseudocode. So I'm going to go buy that item, and then I'm going to do recursion here, where I'm going to do maybe money minus that price and pass in my menu and so on. Maybe I need to pass in a list of items that I'm trying to buy, and so I'm going to come back up here and I'm going to add that as a parameter. And so as I'm working out the pseudocode, it allows me to communicate this very well to my interviewer to say, this is my thought process. Like now that I know I have to pass items or that I'm collecting that item onto a list or something, I should probably pass that in as a parameter. And then if I want to stop as soon as I find an answer, then I need to know like if that recursion worked, then we need to stop because we succeeded. If it didn't work, then I need to sort of unbuy that item. So if we think about it like I'm putting it in a shopping cart and then I'm going to try to spend that money again, this is my repeatable sub-problem. I've bought a sandwich. I had $10. I bought a sandwich because I looped over the menu and that was the first thing on the menu. It's not too expensive, so I'm going to put that sandwich in my shopping cart. So let's use different terminology. So put item in cart. And then if that didn't work, then I need to take that item out of the cart. Because we can't, like we weren't able to find a solution. So if I try to buy that thing, I need to put it back. Well, if you want 2 sandwiches, you can. Crookie Monster was asking in chat, what if I want to buy 2 sandwiches? Well, and this is exactly what we would be building out in our depth first search. So we have $10. We're going to loop over the menu. We want to buy that sandwich. So we put that item in our cart and we call ourselves recursively, but now with less money. So instead of having $10, we have $10 minus the $4 sandwich. So now we're basically calling ourselves again, but now we have $6 to spend. Well, now we're going to loop over the menu again. We don't have to skip that sandwich. It's not too expensive. So we're going to put that second sandwich in our cart. And then we're going to recursively call ourselves with more money again. Well, now we're calling ourselves with only $2. So as we loop over that menu, now we have to skip that sandwich. And so it's going to come back up to our loop and say, well, I actually also have to skip the salad because I only had $2 left and I can't buy the salad either. So now I'm going to basically exit my loop at this point because everything was too expensive. So I need to send some kind of signal back to this check saying like, nah, that didn't work. So I need to return like a didn't work scenario. So now I come back up here and go, okay, well, the recursion didn't work. So I need to take that second sandwich out of my cart. And now I come back and I loop over the menu. Well, I've already bought, so my items list is still just one sandwich. But I'm moving on. I'm progressing to the next menu item. So at this point now it's going to be a salad. So I'm going to put that in my cart because that's not too expensive. And I call myself recursively. So now I've spent $4 on a sandwich, $3 on a salad. I've spent $7. I have $3 left. So now I'm calling myself with $3. So now I loop over the menu again. But now I have to skip that sandwich. It's too expensive. I come back up here and say, okay, what's next on the list? And it's a salad. That's not too expensive. So I'm going to buy that salad. So now my shopping cart has a sandwich and 2 salads. And now I recursively call myself, and now I have 0 money left. So if I come back in here and I just try and run this again, basically everything's going to be too expensive because I have no money left. But I don't want to return, oops, didn't succeed. I don't want to return that I didn't succeed. I actually got to 0. That's actually my goal. And so I would write a base case up here that says if money is 0, then we succeeded. Otherwise, we're going to loop over that menu. So now, because we got to 0 money, that recursion is going to come back here right away and say, hey, that recursion worked, so we can continue to stop. And at this point, we can just keep returning that success and whatever that was. So is this a Boolean value? Am I returning a list of items and returning an empty list of items down here if it didn't work out? So again, I've written the pseudocode in a way that's given me the ultimate flexibility on how I want to go solve that problem without locking myself into, I must loop over the menu this way, or I must, return a list or an empty list, or I must return a Boolean of, true if it worked and false if it didn't work. Because that has an implication on how I write that if statement. But that's a future Ian problem when I actually go to implement the code. But by writing out pseudocode like this, again, it helps me communicate to my interviewer that I've got a problem-solving process. I can show them how I make my decisions. The interviewer can also jump in and ask questions like, hey, tell me about the shopping cart idea. Like, how are you thinking about collecting that in a cart? Like, what data structure are you thinking about using? And now you don't have to change your pseudocode, but now you could say, well, I'm thinking about using a stack. And so could I just append on a stack and pop off the stack later on if I need to take that item back out of the cart? And that would basically be like using an array like a stack, or I could actually implement a stack data structure. Or maybe I want to store it in a dictionary where the name of the item is the key and the value is the quantity of the things that I'm buying. And so placing that item in the cart, I could say if that item's already in my cart, I'm just going to tick up a counter. So again, I've given myself flexibility of how I want to go implement it. But this is a lot less code to write doing it recursively than if I were to do it just with a whole bunch of loops. Because if I do it with a bunch of nested loops, basically every time I take an item out of my cart, that's basically where I need to go continue back in my previous menu. So if something didn't work out and I don't get to exactly 0, then I have to take something out of my cart. But if I've got 10 different things on my menu, then that tells me where I need to go next on the menu. So if I just took a sandwich out of my cart, then I have to progress onto the salad because that's the next thing. And so it's a lot of what we call state management, where we basically have to track the state of all of these loops and try to figure out what's going on. By doing recursion, each sort of iteration of our recursion tracks its own menu. So every time I call the recursion, it's got its own loop over the menu. Where if I did this in a more iterative approach, I would loop over the menu. Inside of that, I might loop over the menu again. Inside of that, I might do some other work. And so I'm looping over the menu in a bunch of places. And it's going to be really easy to lose track of where I left off. Or I may not go through and actually find all of the nested combinations possible in order to get to 0. And so doing recursion in this scenario as a depth-first search is actually a lot less code to manage. It's one algorithm that will solve this problem. There are other algorithms that would solve it, but this one's my favorite. A Carmen says always negotiate, especially if you want to drink in your shopping cart. Cool. Well, let's go back to this original problem that we were looking at. So I wrote some pseudocode in from TypeScript. So let's go back and we'll find another one. So we'll go back to our browser and let's go find another answer. We found one in C++. And kind of glancing over this one. So they've got pointers to list 1, a pointer to list 2. So in C++, it uses the asterisk to mark that it's a pointer. And it's literally pointing to a place in memory. It's not actually making a copy of it. And so that's what these stars are doing. So we're passing in these nodes. And then we're basically just setting pointers to those things again. And then we're starting our third sort of list as we go. And then basically doing a very similar check if they both have data in there. Then it's doing another check that if the value from list 1 is less than the value of list 2, then we're putting the value from list 1 onto our new list. Otherwise, we're doing the old list. And then setting that head, and then it's doing the same loop. So this is actually the exact same algorithm as what we saw in TypeScript. And then basically saying like if I've exhausted one of them, then I'm just gonna like append the rest of the nodes on the end. So that algorithm was actually the same as TypeScript. Looking at Java tends to be a lot more code, but we've got a similar sort of setup here where we've got a bunch new list nodes, we've got pointers to those things, and again, just looking at the same condition as we had in TypeScript. So if list 1 isn't empty yet and list 2 is not empty yet, so as long as we have data on both lists, then we're doing the exact same thing. If list 1 is greater, then we're putting the value from list 2 onto our new list, and so on, and then we're advancing our new list's pointer, and then we're just appending the rest. So this is also the exact same algorithm. So yeah, so we haven't found anything novel yet as far as a different kind of solution. There's an iterative approach. Table of dummies, so basically doing the exact same thing here as long as we have data on both and then append the remaining nodes. And so a lot of these solutions are doing the exact same thing. Ooh, this person's got a recursive algorithm. Let's go take a look at that. I'm always game to learn a new way of doing this. So let's go look at a recursive version of this in, was it C++? Yeah. Cool, let's go dive in on this one. Carmen's got to head out. Good to see you, Carmen. Thanks for dropping by. And you also are an amazing human. Say hi to all your friends for me. Carmen hangs out on the Jonan show. So hopefully they get back to streaming in the not too distant future as Carmen, or not Carmen recovers, as Jonan recovers from his accident. You can check out my stream on Sunday if you want to go check out a little tribute video that we pieced together for him. We had a whole bunch of people in the community kind of send some well wishes to Jonan and put that together in a little video. We played that on the stream on Sunday. So yeah, we definitely wish Jonan quick recovery here. All right, so let's go look at this recursive function. If I'm in the right window. All right, so the recursive function here. So we still have our function. We're passing in list 1 and list 2, and we're still going to be returning like list 3 of some kind. So what are we doing in here? So if we don't have anything left on list 1, then we're returning everything from list 2. So if list 1 is empty, then we're going to return the rest of list 2. And then now we're saying if the list 1 value is less than list 2, we're calling the same function again where we're merging it together. Merging. Okay, so otherwise we're saying if list 1 value is less than list 2, then we're calling our function again where we're passing in the next position of list 1 and all of list 2. Otherwise, we know that list 2 is less than list 1, and so it's basically doing the opposite of this in a recursive fashion, where now we're copying in all of, or the remainder of list 1 but the next position of list 2. And so this is basically going to merge this together in a smaller amount of code. So we can already tell just from the amount of pseudocode, doing things recursively can sometimes be a lot less code, but you know what? This is also a lot harder for me to understand. It's much more difficult to try to guess what this code is actually doing. But way less code. And that's kind of the pro and con of doing recursion. Our technical interviews for junior to mid-level devs. I'm a senior dev, and if I were to go on a technical interview, I'd still be asked questions like these two. Heartbender. Yeah, there's no real getting around it. I mean, my last couple of jobs I got just from reputation and having worked with people and just sitting down and having conversation over like what I wanted in my next job. And I consider myself very blessed and privileged to have had a career that spans, a lot of time and work with a lot of people. And so I can, just kind of lean on my network and go, hey, I need a new job. Who wants to hire me on their team? But if I go interview at a company where they don't really know me, then yeah, they're going to put me through all the paces. They're not just going to look at my resume and go, oh, you've been doing this a long time. Clearly, you know coding. But, I've got some big names on my resume for long periods of time that they would, like the job that I got after SendGrid, basically, I interviewed with them. I went for a walk around the block and had a coffee with the guy. And he's like, yeah, come on by and meet the team and we'll make it happen. And I'm like, well, do you want me to come by and do the whole tech interview thing? And he's like, well, no. He goes, you just worked at SendGrid for 4 years. If you were incompetent, they would have fired you. And it's like, okay, yeah, that's a good point. So, and so they basically hired me with no technical interview, which was fine because I was applying for a management role. And so I didn't really need to be in the code at the time, but I was curious whether they wanted me to actually like get involved in coding. But other roles that I've gotten, which were, coding heavy, like even my role at SendGrid, I went through like the whole tech interview process. And they were grilling me on architecture and how things worked and really low level like PHP, like how PHP did things as far as like memory management and things like that. Because as a senior dev, as an architect, you have to know deeper implications of things so that when something gets implemented, you know how it's going to like have a big effect on other things. So yeah, we get the same kind of tech interview. Sometimes our questions are a lot harder. But, I think it's just as nerve-wracking. Like I still feel imposter syndrome when I actually go interview with companies, and I still feel nervous and anxious about things too. The difference is that I've done some of this enough that I can kind of feel a little more relaxed about it. Internally, I'm still kind of wound up, but I can put on kind of a face of like, oh yeah, cool, everything's normal. This is normal. But I just have better stories basically to back up my answers. Like, behavior stories are kind of a walk in the park for me, because when they say, tell me about a time when, it's like, I got 25 years of experience that I can tell you a time when. Don't get me started on stories. I won't shut up telling you stories. Like, how many stories do you want? And so later in your career, you'll just have a lot more stories to tell. And that can be pretty fun and get you through some parts of the process. But yeah, even senior level devs and like, architects and principal developers and staff engineers, like all those really high seniority level things, they're still going to get these kinds of questions too. They want to know that they're hiring somebody competent to come in and fill that role. So it's the unfortunate thing. I mean, I look at it and go, I've got 25 years experience. Like if I really needed another job, do I really have to jump through all these hoops? And the answer is yeah. They need to know that I can actually sit down and write code and not just say I can write code. They would actually want to see me go through this process. And so I would actually sit down and I would actually pseudocode out, very similar to what you're seeing me do here, except I wouldn't have someone else's code to look at. I would be actually coming up with the pseudocode on my own to solve these problems. So again, kind of abstracting this back to the goal of what the session was about tonight is like, how do we reverse engineer Leetcode? And basically what I was getting at is go find a problem on Leetcode. So let's back all the way out to our list of problems. So just go find a problem on here and stick with easy and medium ones to start with. So divide two integers. I've never done this one. Given two integers, dividend and divisor, divide the two integers without using multiplication or division or the mod operator. The integer division should truncate towards 0, which means losing a fractional part. So 8.345 would be truncated to 8, 2.7335 would be truncated to 2. Return the quotient after dividing dividend by divisor. So this is an interesting problem where you've got to understand the math of how numbers actually divide. Now it's telling us that we can't use multiplication, division or the mod operator, but it sounds like we could use the subtraction operator. So we could just sit in here in a loop and just subtract the thing over and over again and tick up a counter for how many times we subtracted it. And then if we can't subtract it anymore, if the remaining amount is greater than the divisor, then we're done, because it tells us to like round off any remaining portion. And so at first glance, that's how I might approach this kind of problem. Now, I also get told I tend to overcomplicate things. So that could definitely be a thing here, but let's go look at the discussion forum. Let's go see how other people have solved this. So we have a login or an O1, got one in C++, and a recursive solution. So here comes recursion again. So 7 divided by 3 is 2. So we have an integer count, 7 minus 3. So they're doing subtraction equals 4. And 4 is greater than 3, and so we do this again. So we tick up our counter, and then 4 minus 3 is 1. 1 is less than 3. So it looks like it ticks up the counter again, and it returns that as the answer. So that was the recursion, and then the Leetcode, the C++. So this one's a lot longer. We're saying if it's 0, return 0. If it's 1, return the dividend as is. Otherwise, if it's our minimum value, yeah, so we have to, so in a lot of tech interviews, they may say like, hey, could this throw an error? Like if I just say like, oh, I'm just going to do the subtraction thing. Well, if the number's already negative and I subtract that number, it's going to be an infinite loop. So I may have to look at like the sign of the number, like is it positive, negative? So this is basically just doing a whole bunch of like sanity checking, as we would call it. Like, can I actually do this operation on this number? And maybe keep track of what that sign is so that I can put the sign back later if I need to. And basically saying if it's greater than 0, then it's returning these things. Okay. And then to actually do the division, then again, yeah. So it's just doing subtraction, it looks like. So my gut check was kind of the right sort of approach. And so this is how we would write out that pseudocode. Is we would basically sit down, we would look at someone else's answer and go, yep, that's how they solved it. Or, oh, here's a new interesting way that somebody else solved it. I wouldn't have thought to do it that way. Well, now I've got more tools in my arsenal. Later, the next time I see a problem, I might recall like, oh, remember the way that other person did that? I wonder if that would apply here. So as we kind of work through the pseudocode, and kind of go back to what I was doing in the editor just to kind of describe it. As we kind of remove the parts of the pseudocode that are the same, then we kind of boil it down into a strategy that we would see a lot more common. For example, if I kind of revert all this back to the depth first search that we did earlier. Here's the thing with backtracking. Loop, put it in the menu, recurse, and then take that item back out. This is every backtracking algorithm in 4 steps. You have a list of decisions, you act on a decision, you repeat all of the work from the previous thing, and if that succeeds or not, then you put that item back. So let's go solve a maze. Well, I have a list of decisions to make. I can go left, I can go straight, I can go right. And so I'm going to act on that decision and say, okay, I've gone left, so now I need to like go back down that corridor. So now I need to repeat whatever work it took to get me to an intersection. And now that I get to that intersection, I've got a list of decisions to make. I can go left, I can go straight, I can go right. But let's say I'm at a dead end. Well, now I need to return from the recursion and go, that didn't work. I need to undo that decision. I need to walk back down the hallway to the previous intersection so that I can go back to its loop and go, okay, well, going left didn't work. That hit me a dead end. Let me try and go straight. Oh, I can't go straight. So I have to go right. So let me go act on that decision. And let me go repeat all that work again until I get to another intersection. And if that worked and got me to the exit, then I can be finished and my recursion can end. So this is every backtracking algorithm in only 4 steps. You loop over your decisions, you make a decision, you repeat that work, and then you undo that decision. And so this is also kind of the general algorithm for a depth-first search. And so I would like write these 4 steps down on a Post-it note and put it on the edge of my monitor or something. And so the next time I see a problem where it sounds like I've got to do something like this, I can kind of glance at that Post-it note and go, I wonder if I could solve it that way. And now I can say like, hey, I'm going to try writing out some pseudocode because I think this might be a depth-first search or it might be a backtracking algorithm. I just want to like just sketch some stuff out. And if it works, great. And if it doesn't, go, no, I was wrong. Let me think of another answer. Like I'm just going to take a moment and think through a little bit more and try to decide if that was, if I can think of another strategy. Or maybe you think of a strategy, but it's not like the most optimal one. That's okay too. I'd rather see finished code than somebody sitting there scratching their head for an hour. I would rather see you write some kind of janky, slow code and at least get a solution than not even attempt the problem or get totally hung up on it. Cool. So that's pretty much all I wanted to go over. Was like, how do we get in the mind of someone else? How do we see how somebody else solved it and reverse engineer that so that we can write out our own pseudocode and then study that pseudocode as a way to then come up with these strategies for how we want to solve these kinds of problems. Now, on Leetcode, when we go to this problem list, we can actually come in here and we can actually go look for, let's go look for a particular kind of problem. Hash table, math, depth first. So let's go look for depth first search problems. Well, now that I've got the basic list, let me go back to, I'm on the browser. So now that I've got kind of this basic list of depth first search problems, now I can go apply these 4 steps. I realized that I explained this whole thing without actually showing the code. But this is every backtracking algorithm in 4 steps. And we can kind of repeat this similar algorithm for most of these problems that are depth first search problems. It may not be exactly that way, and there may be like other lines of code to do in between. Like there may be other instructions to do in between these instructions, and our base case may be a little different, and what we do if we fail through our loop may be different. But it gets us half of the way there, maybe 60% of the way to a solution, just by understanding these 4 steps. And so as you study different kinds of problems, this is where Sean Prasad's list Leetcode thing comes in really helpful, because now I can come in here and I can say, okay, well, show me all the depth first search problems. And maybe I'm interested in applying at Twitter. So go show me all the depth first search problems that Twitter may ask. And now I can go practice these ones specifically. And because I've got those 4 steps, I can start every algorithm with those 4 steps and then figure out what else do I need to actually solve the problem. And so it can kind of streamline that study a little bit more. So big thanks to the person that asked me to kind of do that. They asked to stay anonymous, but I wanted to go into a little more detail on how I would actually go in, extract like those answers, write out the pseudocode, and compare that pseudocode in order to now boil down that strategy so that I can study that strategy and say, for a depth first search, this is the strategy I want to do. Now you can go certainly find all kinds of online resources and teach you like this is also like a pseudocode approach to a depth first search or breadth first search or heap problems and so on. But I find that by looking at other people's answers, it helps you kind of get into the mind space of someone else and how did somebody else solve it. And so I think it's a good way to kind of dive in on those kinds of things. So hopefully that was helpful for everyone. Zooey's got to go. Hope you're doing well. Good to see you as well and chat again. Feel a little less nervous about your tech interview tomorrow. Well, good luck tomorrow. I hope it goes great. Let me know how it goes. Check in with me and let me know how it goes. Reach out on LinkedIn. And I'm always curious like what kinds of questions you get asked and so on. So I'll wrap up here. I'm going to get this up on YouTube a little later. If you watch this on YouTube, I hope you made it this far. Hour and a half is a long time for a video, so I appreciate you hanging out. Like and subscribe, all that stuff. And go check out the website at techinterview.guide. I've got the email mailing list on there for technical problems and behavioral problems. So yeah, definitely go check those out. And we'll catch you folks on Sunday. Have a good weekend, everyone. Actually, no, sorry. I will not be streaming on Sunday because it's Halloween. I'm going to be busy handing out candy. So I will not be streaming this coming Sunday. So I'll make sure to put a note up on Twitch that I will not be streaming this weekend. But have a safe weekend. If you're going out trick-or-treating or handing out candy, be safe. Hope everybody stays safe and warm, and be kind to one another. And we'll see you next Thursday. Cheers.